So the two properties are, number one, the PDF values for all values of x that are defined, like 1 to infinity, all the PDF values must be greater or equal to 0. It can be 0, but it cannot go below sea level. Remember that? Yeah, so in other words, in the PDF diagram, the function, we can only see the curve being above sea level or on the sea level, 0. It cannot go below sea level. That's the idea. And the sum of all x values within the sample space, the sum of all the area under the curve is equal to 1. Even if we have to go to infinity to chase down the last height, the last area, we go there and we must add up to 1. All right, it's not approximately 1. It's not 1.0001. It must be exactly 1. And then and only then can we say that the PDF is a distribution. Or can we attach the word PDF to this function of x? So all functions can be drawn. You can draw x squared, x cubed, whatever. But not all functions are PDF because they don't satisfy both properties. Yeah, so that's why we need to ensure that they are followed, both of them. So now, let's say that here's an exam question. Prove that PDF of x or equals to 1 over x squared. Show that this, when it's defined from 1 to infinity, is a distribution. Of course, it is continuous, yeah, because it is continuously from 1 to infinity. The x value may be discrete, remember, or continuous. The y values will be always continuous. So we don't have to worry about what happens to y values being discrete. It's always modeled under a continuous space. So show that it is a probability distribution. First, we must argue that the values for PDF of x, right, will always be non-negative. Yeah, because it's x squared. Even if x is negative, it will be positive, right? X squared is positive. So it will be never negative. So we have satisfied the first point. You have to say it. If you're being examined, then you're being tested. Did you remember the first point, right? So you have to say it. So we write this out, even though it sounds very trivial, it's obviously true, but we're being tested. Did we remember to check these two properties? Yeah? And the second property is that when we integrate from minus infinity, and because from minus infinity until 1, the probability is 0 anyways, there's 0 area anyways, we just fast forward to 1 to begin at the lowest defined value for x. Yeah. So from minus infinity to infinity, the PDF function, all right, do we get 1? So remember the form for 1 over x squared when we integrate it is minus 1 over x. And we will put a copy of minus 1 over x minus another copy of minus 1 over x, where the top number is substituted into wherever x occurs, and the bottom number is substituted into the second copy whenever x occurs. Yeah. So to just fast forward this calculation, 1 over infinity, 0. 0 minus negative 1, we get positive 1. So a beautiful 1 pops up right here, not tiny little bit more nor less. Hence, it is a proper continuous probability distribution. So that's the end of proof, right? And that's important to check if you are being asked to check. If, however, in solving application problems, typically that is already being checked or else being fulfilled. So you will be told something like the time that it takes John to go from his home to office is modeled by the following PDF, right? And they will give you this PDF. And the fact that they call it PDF means it is a distribution function. And so it better be satisfying both criteria already, right? So that's the part that you don't have to worry about. But in my example here, it is to just test you on the basic fundamental understanding. Next is cumulative distribution function, which is tremendously useful to find probability. So question is, can we calculate CDF of x. And recall that this was defined in exactly the same manner. It is the probability of all values of capital X being less than equal to the given little x here. So this little x can be 5, can be 3, can be 2, can be 1.2, and so on. So in the discrete case, we just use summation. In the continuous case, we use integration of the PDF function for all values of u that are less than or equal to x. Okay, less than or equal to x. So here's an example. The same distribution function as in this one. All right. So PDF is being defined like this. And let's ask, calculate the CDF of 2. Calculate the CDF of 2. Well, then we rewrite as integrate from 0 to, no, sorry, we are calculating this one. Sorry, let's look at this one. PDF, calculate the PDF of the CDF of 3. Calculate the CDF of 3, and then hence calculate in general the CDF to any value w that we give. So what we do is we integrate from 1 to 3, because 3 is the stopping point that we were told to do. Then we integrate the 1 over u square. Remember, the form is, we have already checked, is minus 1 over u, 3, 1, right? So we copy minus 1 over u minus another copy of minus 1 over u, where 3 goes into wherever u occurs in the first copy, 1 goes into u wherever the u happens in the second copy. So after simplification, you will get 2/3. Now, what if we want CDF of 4, 5, and 6? That will be quite a chore to always have to integrate all the time. So what we do is we say integrate all the way to w, and then later we change w. For now, it's fixed. I just don't tell you that actual number. So we will integrate from 1 to w. All right, but for simplicity, we can just put it as x because there's no conflict here. So we put it as x, 1 over u square du, and the form that, the integrated form of 1 over u square is minus 1 over u, going from 1 to x, and then we use the same thing again, minus 1 over u minus another copy of minus 1 over u, right? Where we substitute u in the first copy with x, u in the second copy with 1. And after simplifying the terms, you will get 1 minus 1 over x, or 1 minus 1 over w. So no problem at all. Let's try. What if x equals to 3? 1 minus 1/3, that's 2/3, right? We get this right away. So that's very nice and easy. We just use one completed formula. Will do. We don't have to integrate at all. And this can be done in calculator. So another example, a very quick and simple one. What happens if PDF is a constant like this, 1 over 6? So the graph is probably very easily imagined. It is defined from 0 to 6. All right, and the height is 1 over 6. Sorry, it should be a horizontal line. You get the idea, right? So you need to find the area here. So to get to 2, we need to integrate from left to right and stop at 2. So we do that from 0 to 2, the PDF. So PDF happens to be just a constant. Constant, after integrating, we can take out the constant outside and integrate 1. 1 after integration du is just u itself. So u minus u. We put a 2 in the first u and a 0 in the second u, right? So what we get is 2 over 6, and we get 1/3. Now you might again recall that area under the curve, area under the PDF, this horizontal line, is if it's a very recognizable shape like a rectangle here, then it is certainly possible to use our height times width formula. So the height is 1 over 6 and the width is 2 units, and straight away we get 1 over 3rd. So again, that's precisely what the integration achieved. That even though integration might sound complicated, right? It is the correct thinking. But in simple cases where the area formula is well known, well understood, and you can easily use them, by all means use them. You see that the answers are exactly the same. What about a generalized value such as W, right? So in this case, we will take W as if it is a number, but we don't know the number. So it's not a variable. All right, so we just take it as a number and we don't know the value until later on. So what we do is the same, integrate from 0 to W, the PDF, and the PDF integration is exactly the same. We'll write a U minus U and put a W in the first U, 0 in the second U. So we get a W back. So W times 1 over 6, we get W over 6. Now, we can, of course, do the same derivation in using geometrical formula, right? So we can say we have an arbitrary width here, all right, from 0 to W, and we would like to find this area when I tell you eventually what is W. So can you give me a general formula? Answer is yes, because height times width. Height is 1 over 6. 1 over 6, yeah. And the width is W minus 0, so that's W, right? So answer is, the formula is W over 6. Exactly the same like how we use integration again. So in simple cases, and likely is something you will encounter in your homework or exercise or exam, then you can certainly use the geometrical formula, even circle or semicircle or quadrant. But in general cases where, the PDF gets a little bit more complicated or even segmented, like 1 to 50 is 1 over x squared. 50 onwards is 1 over x cubed. Then you don't really have, some ready formulas to apply, and so you have to use integration in general. Still, that is just looking up the integration table, and it's really nothing so complicated to worry about.